In the previous lessons, we have completed the assembly of both the car and the remote control. Now, there is only one final step before the car can start running, uploading the code. First, make sure you have downloaded and installed the Arduino IDE from the official Arduino website. Open the software, paste the code into the main interface, and select the development board. Search for Uno, choose the correct port, and ensure proper connection. Click Upload and wait for the code to be written. Let's first take a look at the car's code. At the beginning of the code, the software serial library is included to create a software serial port for communication with the HC05 Bluetooth module. Then, a software serial object Bluetooth is defined. Pin 10 is used to receive data and is connected to the module's TX pin. Pin 11 is used to send data and is connected to the module's RX pin. Motor 1 uses pins 8 and 9, while Motor 2 uses pins 4 and 5. In the setup function, we initialize the serial monitor to facilitate data debugging. We initialize Bluetooth communication with a baud rate of 9600, enabling communication between the car and the remote controller. The motor control pins are set as output to ensure the car can execute commands correctly. Forward means both motors rotate forward, making the car move forward. Backward means both motors rotate backward, making the car move backward. Turn left means the left motor rotates backward while the right motor rotates forward, making the car turn left. Turn right means the left motor rotates forward, while the right motor rotates backward, making the car turn right. Stop car means all motors stop, bringing the car to a halt. In the main loop, first, monitor Bluetooth data to check for incoming commands. Then, parse the command and execute the corresponding movement control. F represents moving forward. B represents moving backward. L represents turning left. R represents turning right. S represents stopping. Finally, print the status to the serial monitor for easy debugging. Now, let's take a look at the remote control code. The remote control code is similar to the car code, also including the software serial library for communication with the HC05 Bluetooth module. Define the Bluetooth software serial. Pin 10 connects to the module's TX, and pin 11 connects to the Bluetooth module's RX. Then, define the joystick input pins. Joy-X is connected to pin A0, controlling the left-right direction. Joy-Y is connected to pin A1, controlling the forward-backward direction. Additionally, set a threshold value of 512 to determine the joystick's deviation. In the setup function, initialize the Bluetooth software serial with a baud rate of 9600 for data transmission. Initialize the hardware serial for debugging, allowing real-time monitoring of joystick input data. In the main loop, first, read the joystick's X and Y axis values and print them to the serial monitor. Then, send control commands based on joystick deviation. When the X-axis is greater than 512 plus 100 and the Y-axis is pushed forward, send a right turn command. When the X-axis is less than 512 minus 100 and the Y-axis is pushed forward, send a left turn command. When the Y-axis is greater than 512 plus 100, send a forward command. When the Y-axis is less than 512 minus 100, send a backward command. When the joystick returns to the center, send a stop command. Transmit the command via Bluetooth to make the car execute the corresponding action. Finally, add a 100 milliseconds delay to prevent excessive command transmission frequency. Once the code is uploaded, you can control the car using the joystick. You can also attach a robotic claw to the car and join the ball-grabbing battle for an even greater challenge. Don't forget to turn off the power after use to prevent battery drain. In this lesson, we successfully completed the code uploading and pairing test for the smart car and Bluetooth remote controller, achieving basic wireless control functions, including core control commands such as forward, backward, and turning. Starting from the next class, we will officially begin learning embedded programming and explore more advanced technical applications.